Welcome all. Today we are going to see that unit 2. This is one of the searching technique method in follow by the some of the uninformed and then informed problems. So this is one of the very important problem in the AI with the help of like the BFS, that is a breadth first search, and then uniform cast search, depth first search, along with the working principles and then the main advantages and then limitations, everything we are going to focus it, and then the main time taking the time complexity also we are going to discuss. So this is the thing, and we can just understand the searching techniques and then to solve the real world problem. So these also we are going to cover into that, and then the search technique, the procedures, and follow by the real world also we are going to discuss about the thing. And the first one, the search. So what is meant by the search? Search as a, that is a universal technique of solving the problem in the AI concept, and this is one of the followed by the different kind of the strategies problem we can analyze and then apply for our the real world problem over here. The main search method, it will be just observe the state space method, space search method in following by the other types. The important thing is whenever we can focus with the solving the problem, so we can analyze these kind of the criteria like the state space and then start space and then goal test. So based upon the search of the problem, we can just to overcome our the all those the problem methods. So then only we will get the good goal also. What the first one, what is meant by the state space method? This is to observe the set of all possible state where you can be moved. Okay, so this is one of the things. So it should be like observe the all possible state like left side and then right side, top side, bottom side, whatever the thing is happening here. So it should be just observe the all possible parameters. The next one, start state, and this is one of the start from the where the search begins. So it should be just always focus in the starting point of the statement. So this is why we can call it as a start state, because based upon the starting thing, so we can just analyze with the step by step of the process, and then we have to just focus on the goal state also. Okay, the starting state is some other important methods for example like a travel salesman problem, like whenever we can start with the starting point, at the end of the point also we have to just come into the starting point. So like that. Okay, so the starting point is a very important role for solving the problem. And next one as the goal test, and this is one of the important thing for the goal test, and this is one of the starting to the reach out the final goal. This also we have to just compare into the whatever the goal it should be reaching, so we just compare into the goal level of the values also. So this is the important three problem solving techniques for the analysis of searching method. So these technique, it will be just solving the sequence of actions. So that sequence of actions we can call it as a plan. The plan, it could be like the transform the start state to the goal state. So in between the plan also very important role for solving the all those conditions, we will achieve our answer. The next one, search problem component. So we are having the search problem component. So these component as the represent the all possible state. These actions, it could be like define the possible move available to the agent, and then the transition model describe the result of each action, and then path cost also we can measure with the total cost for the from state from it should be like the start state to end state. And this solution is sequence of action leading to the goal, and we can always find the optimal solutions in the level also. So this is one of the important thing for analyzing the search problem method. This is overall the definitions. In particularly the search tree or the search tree, so we can represent the root node and then follow by the child node process also. We can travel the whatever the technique we are having, and whatever the type we are having, and whatever the important role and then rule we are having, we can move up into the searching process from the starting to the ending node for the each level. The next one, actions. So the action, it will be just to following for the whatever the rule is happen, we can just make with the actions. and then follow by the transition model. We want to just analyze and then taking with the all those information, and then we can record the information into the particular position of the value. We can make with the some transition model also, like the column wise, row wise, what is the action, it should be real actual thing is happening. We have to just record the all information into that. The next one, path cost. So we can just make with the, so what is the exact path from the starting node and then middle node and then ending node, everything we have to just analyze the value. That particular value, it will be stored into the transition model. The next one as the solution. So final solution, definitely we are going to expect, so particular action, it will be just to connect to the lead to the starting node to the goal node. So that the thing definitely we have to focus. So this is called as a solution. And then optimal solution. So always we can just connect with the lower cost of the solution with the among to the solving our final solution. Okay, so we are having the lot of value, but in particular some other problem we are having the lot of value. In particularly we want to choose the particular value that the minimum value means. That's why we can call it as a optimal solution, that is a optimal value. So minimum value, yeah, minimum value among the all those value, we can just take with the minimum value and then particular in the direction. Okay, so this is called as a searching techniques for the general component. And the next one, we just move on to the general search algorithm. So this is one of the general search algorithm for solving the method. And the general search method, it will be just focusing on the basic foundation of the level. Okay, so the this algorithm, it will be just what is the initial state is happening and then repeatedly expanded node. Always we can check with the like whether the current node is the goal node or not, and successor node or generated, and then we can check with the adding to the fronter thing. So every process we can continually until the goal is found or not. So that the thing also we have to just focus into the generic model. Okay, so whenever we can just initialize the first step, so be among the first step we have to just focus until we will get the final outcome. So that the thing, so repeat the process also, sometime it will be happening, apply the each operator and then generating the successor node and then adding the result node, everything it will be recorded into the before yeah, record into the requirement of before the slide. Okay, that is a search processing slide. And next one is as the this is one of the example of the searching method, like TSP problem. Already I have mentioned, no, TSP. So TSP, it will be starting wherever the fix with the starting position into the same starting position, same thing it will be just again we can come with the starting position. And then 8% problem, tic taco, n queens problem, tower of Hanai, and then water jug problem, blocks of world, vacuum cleaner, everything we have the search method. That search method, it will be applied for the state space search method. So that state space search method, it will be just applied to the all possible way, and among the particular rule and then particular condition, we will get the final outcome. And next one as the parameter of the search evaluation. This is one of the important thing for taking our uninformed and then informed search method. And the first one is as the completeness. So this is one of the guarantee for to find the solutions in the final thing. And then optimality. So this is one of the, always we have to check with the optimal rule and then optimal value we have to find in at the end of the outcome. And the next one, time complexity. So the time complexity is the very important role for taking the time calculations. Okay, so in particular method or particular process, how long it will be taking. Okay, everything we have to just measure into that. And the next one is as a space complexity. So this is one of the memory oriented thing. So it will be analyzing, so how much of the storage it should be wanted to store the particular process, everything we have to find the pakka manner. So this is one of the space complexity. So this is one of the four important thing for searching our thing. So completeness means we have to just find the final solution. And then optimality, this is one of the very good parameter for the thing, because we have just to analyze and then conclude the final solution of the minimum path level. And then time complexity, so it should be like taking the overall the problem measures, and then space complexity, it will be taking the memory oriented level of the space technologies. So this is the parameter of the searching method. Now we can just move on to the uninformed search 3. So here we are having the two kind of the types, so informed and then uninformed. So we will discuss the diagrammatical representation also, but now we are going to see the uninformed search method. It will be just connected into the heuristic search method. So heuristic search, we have the current and then the next path of the value we are always calculating into that. Okay, so this is one of the important thing for the information. And the uninformed search, so we are having the like uninformed search in this searching method. Okay, we can call it as a blind search method, because what now we don't have any proper rule and then proper method over that, but anyway we need to get the proper answer. So that is very very important thing. Whenever we can compare with the informed search method, so we are having the pakka rule and everything, so we want to just move with the informed search process. Okay, that is very very important thing. And this is the thing. And this search method, it divided into the already I mentioned, no, two type of the uninformed and then informed searches. Uninformed, it will be just providing the proper info, proper does not provide the proper information. At the same time, informed search, we can just provide the proper informed with the help of the heuristic function. That is the main difference. And then uninformed, always we can call it like the blind search, because of we don't have any rule and then any what is that constraints over there. But informed thing, whenever we can, even though we can compare with the informed method, so we are having the some certain rule and then certain some process, it will be happening into the thing, and then it will be take over for the heuristic search problem, and then uninformed as a blind thing only. And then the uninformed search, we can call it as a blind search, always we can discuss like that. And this is don't have any knowledge about the goal location. If explore the knowledge or nodes into the systematically until the goal is found. Okay, so this is one of the brute force approach, because it will be always talk about the brute force approach only, because of what now, it will be just to help over like the brute force way only, it will be take over. Okay, so and then this set strategy, it will be just take over for the non-goal state, we can call it as a non-goal state. And this is one of the informed search method or heuristic method. I'm telling about the like informed search method. Okay, this is one of the thing. And uninformed search method, always we can talk about like the brute force method. So what is meant by the brute force method means, so this is one of the problem solving approach. So every possible solution until to find the correct node, that is the main thing for the brute force solving method. It does not any shortcuts and then extra knowledge. So it will be just a guarantee for finding the proper solution. That is the only one solution of the guarantee here. And it may take the long time, because explore the unnecessary path also. Okay, that is the important thing. And the brute force method, that does not contain and does not maintain any domain knowledge also, only it will be just maintaining the information about the current problem. And but anyway, the brute force approach, it will be just to focus how to travel the tree, and then how to identify the leaf node, and then whatever the level it should be present, and then it should be just to find the goal node also. So everything, it should be just to combine into that. Okay, everything we have to just focus into that. So then only we will achieve the good result. That is mean by as a uninformed. Uninformed, always it will be take over like the brute force method. And the same time as the informed search method, so we can call it as a heuristic search method. It will be just containing the domain knowledge, and then maintaining the all information about the searching problem also. So how to travel the thing, and then how to achieve our goal, everything it will be just maintaining the all those informations. So this is the main difference between the uninformed and then informed. Already we have discussed the brute force. So brute force, they having the some certain methods, so how to travel, and then how to identify, and then goal store belong based upon the thing only. So the uniformed search, it will be just to take over the all informations. So that's the thing, we can call it as a blind search. Okay, so this is the sample diagram. So searching algorithm, so we are having the two criteria of the two criteria and two types of the searching algorithm. The first one is as a uninformed method, that is a informed method. So uninformed, we are having the different kind of the searching methods are available here, and then informed method, we are having the two type of the searching process is that. So here in the follow by that, we are going to see the one by one. Okay, so first we can see the like the breadth first search method with the following in the uninformed process. Before going that uninformed search, it could be just there is no information, and then some of the information, very limit of the information only happening here, and then it will be take over like the brute force method. So here these are all the types of the uninformed search. Already we have discussed about that thing. And the first one as a breadth first search. So here the breadth first search as a short form is as called like the BFS. Okay, so BFS as the short form of the thing. So here we can just talk about like the breadth first search is a common search strategy. It will be traveling as a tree or graph. Okay, so that is the main thing for happening for the BFS. And the explore these information, it will be always like the tree and then graph method. It will be traveling, and it start from the root node to all visit the all neighboring node. So that is the main constraint. Before moving the next level, it will be just visited to the all node. So that is very important. It will be just visit to the like what the level based level. Okay, it's like the left to and then right move of the level. So BFS method, the root node and they expand into the all possible node. What all the should be present in the level based level, it will be visited. Okay, that is the main thing. And the breadth first search method, it should be like the example of general graph search algorithm also. And this is it can be implemented as a FIFO-Q data structure method. Okay, it will be just following the FIFO method. Okay, so first in first outcome. And next one, the BFS travels of group procedures, the spanning tree as the final result. So finally we can just make with the spanning tree also. Okay, so that is the thing. And then this is the important notes of the BFS method. And this is one of the structuring information for the BFS method. Okay, so we are having the parent node, that is a root node, and followed by the child process. So S and then A, B, and then C, D, G, H, and then E, F, and then I, and then K. This is one of the node of the information over here. So based upon the node of the information, so we want to just move with the step-by-step process in the level-based method. And this BFS maintaining the two queens, and then one queen store the nodes waiting to the explode, and while other queens, it can be proceed the nodes and everything, it will be record until the result will get the easiest thing. Okay, that is the important thing. And first one, we can start with the root node as a S, and then that is a level 0, and then follow by this node, we can just move into the level based level. So S to A, and then A we can reach out, and then just to travel with the B, and then B, because this is the level 1, we are having the two nodes. Okay, follow by the 8, follow by the S. And next one, B, it will be just going to the C, and then C it will be visited, and then again it will be come out to the level based, and the C to D, and then D to G, and then G to H. And then once the H is over, there is no other node is there, means again it will be just to come into the E part, and then E as the starting position of the left node, and then E it will be travel to the F, and then F it will be travel to the I, and then I it will be traveling to the K. So this is the end node. So start node is S, and then end node is K. So the breadth first search, it will be just to travel into that like level based method only. So whatever the maximum level, it should be present in the node. Okay, so every nodes it should be just to travel, and then again it will be coming into the next level of the starting position. Okay, so this is called as a BFS method. So this is the first spanning tree for the final after the thing. So like what now, the connectivity process. Okay, so how does work for the thing, like the one queen, it will be stored into the explore the information, and then each and every node it will be going to the storing into the part. So here the minimum, the P, and then P can be just found the breadth first search, and then Q1, Q2 model, everything it will be just handling for the connectivity of the process, and then breadth first search also. The main important thing for the time and then space complexity here. The breadth first search have this time complexity, this is the time complexity of the formula. Okay, so T of P into 1 plus P square and then T square and then omega of P of power of D. Okay, so this is one of the time complexity. So we have to just maintaining our timing process until the process it should be complete. Okay, so that is very very important thing. And here we can just P as the already we know like the branching the factor, and then D as the depth of the shallowest solution. So always we can just find out the optimal value of the level. Okay, that is important thing. And then the next one, the space complexity. So space complexity also it will be just depend into the memory size. So whatever the technique, so how long it will be just going, and then particular how much of the level also it will be taking for storing our value. So that also we can represent as a P of D. Okay, and then next one, completeness. And the completeness it will be just to go roll out like the shallowest goal state. Okay, finally we need to complete. So that is the important thing. And optimality we can just find the very limited and then very low level of the optimal cost. Okay, so which is the optimal value and then optimal cost we have to find. So this is called as a PFS, and then time and then space. So this is the already we have just discussed with the thing and BFS. And now next we can go with the other search method is the uniform searching method. So uniform searching method as the one of the important concept. Okay, so here the uniform cast method it will be just whenever the different edges have the different cast it will be happening, and then instead of the expanding the shallowest node, and it should be just extend the node with the lowest cumulative cost also. And it is use the priority queue and always choose the cheapest path first. So that is very very important. And when all the edges cast are equal and uniform cast such behave like the breast versus search also, that is very very important. So uniform cast structure we have to just maintain the uniform level. Okay, with the cost of the information, and then we have just to roll out into the next DFS method also. And the uniform cast search it can be implemented into the priority queue also, that is very very important. So we have to maintain the priority queue also here. Okay, so that is important thing. Because of what now, so we have to just maintaining the the optimal value. Okay, so everything we have to check into the thing. And but the main goal is what now, we have to just find out the minimum layer level, that is a lower cost of the level in the particular tree. That is the thing. And it will be just replicable for the BFS method. Okay, that is a breadth first search method. Based upon the breadth first search method we can do it for this process. Okay, and so this is one of the structure for the thing. Okay, so we are the starting node is what now S, and then the ending node is G. Okay, so here we can just call out like what now, the S, and then we are just comparing to the value like 1 to 4. So which is the minimum value. So based upon the thing we can move into that. So 1 and then 4 we can compare into that. So 1 is the least value, that's why we can fix with the like as the A node as the comfortable node. And next one, next node we have to move. We are having the three level of the nodes in the level 2. Okay, so C, D, G. So here we want to just move, check with the optimal value also. 3, 2, 5. So here the 2 is the one of the very very minimum value. So that's why we have to just fix into the D as the position of moving the level. Okay, next one as the next level as a level 3. So we are having the level 3 process in the last. Okay, but here what the thing now, so in the ending node also automatically it will be coming. Okay, in the G as the ending node. So always we should just connect into the G. Maybe if the E is lesser means, so there is no problem, because we have to just fix into that this is as the final node. So that's the way only we have to just. And uniform cast it will be just to check with the breadth first slide. That is the BFS method also, because whenever the one node is passing and then connecting to the next node, okay, we have to check with the level based this one and this one what is the value is happening. Okay, everything we want to check, and then decide with the minimum value, and then we have to move out to the next level. So this is called as a uniform cost method. So always we have to find the lowest cost in the with the help of the BFS method, and then priority queue also we have to just focus into that. Okay, so in the following thing, this is as the one of the proper node for analyzing our unicast level. So this is one of the general category over there. Okay, for it can be represent like the uniform of the cast, and the starting node and then ending node they will give means, so automatically we can just move into the next level of the thing. And always we have to just fix with the cumulative cost, and then the what is that, the learning experience, everything we want to just decide into the part. Okay, and this is one of the starting position for the A, and then next step where the node is going. Okay, 5 and then 9, and 5 is the one of the minimum cost. Again it will be travel, and then travel here we are having the two node for the 7 as we are going to decide, and then after the 7, so we are having the two node for the 13 and 14. Okay, so we can help BFS method, we can help with the BFS method, we can check with the level based information, and then we can decide with the G as the final node. Okay, so this is one of the important thing for the component of the level. And next we can come up with the like the four kind of the parameters over here. Okay, so first here we can just see with the completeness process. So we have to complete with the proper level of the final outcome over here. Okay, that is very important. Okay, so this the thing is happening, and then next one as the time complexity over here. Okay, so here we can just talk about the time complexity as the based upon the formula for this is the formula. So we can just always take about like the branching information, and then storing the cost of the value also. And then space complexity, this is one of the space complexity for we go of the branch of information, and then and then complexity of the level. Okay, so this is one of the thing. And yes, so the C belongs to the number of steps in the thing, and then epsilon it will be just closer into the goal state. Okay, so everything, and then optimal we can just find the good optimal in the lowest path. This is one of the uniform level. And the next one as the DFS method, and DFS is the traversal for the searching method, that is a depth first search method. This algorithm it will be always taking with the root of information and follow by the next level also. Okay, the backtracking information also it will be happening. Okay, whenever we want we have to just backtracking into the last stage to the before stage. So this is the thing. And the DFS method it will be starting initial node into the G, and then like just goes and then deeper into the goal state also. Okay, so backtracking also it will be applicable, and then it will be maintaining the stack in the DFS method. Okay, we have to just follow the stack method. And the discovery edges, block edges, everything we have to just follow. So discovery means what now? This is one of the unvisited node, and then edges already visited we can call it as a block edges. So this is one of the primary information for the solving the DFS method. And here the DFS method, whenever we can go with the starting node, the starting to the ending. So first what the thing we are going to do, the S as the starting position, and then next we can move into the next level of the position. Okay, and then the next A, where is the depth of node. Okay, so A to B as the depth, and then B to D as the depth. Okay, so whenever we can start with the starting node, and then whatever the left side is representing the node, we can just go with the depth level of the process until where the node is wind up. Okay, so that is one important thing. So yes, goes to the A, and then A goes to the B, and then B goes to the D. D as the depth node, and again it will be just backtracking the level, and then come up with the E. Okay, and again it will be backtracking to the C, and then C, and then connected with the G. So this is one of the backtracking approach also it will be just happening here. Okay, so this is called as a depth first search. So depth means what now? It will be just connected with the depth level of the particular node. Okay, that is called as a thing. And then once the depth level of the node it has visited means, again we can go with the next level means we can just apply for the backtracking method, and then we have to reach out the final goal. So this is one of the level based information of the DFS method. This is the sample structure for the path level. So finally we have to just represent the answer for the, this is the node represent for where the node it has visited. Okay, the next one, the DFS, it will be just working principle for the thing. The adjacency node also it will be happening, and then stack node also it will be taking the push and pop or everything it will be taking. And the main important thinking, so backtracking also it will be working model for the thing. So this is one of the sample structure for the like the coding. So how the stack is working, and then how the process is visited for the unvisited, and then visited three, and then push and pop information for the thing. Okay, this is one of the general coding for the like the DFS method. Okay, and this is one of the recursive process. So particular node is visited, again we have to just visit for the before the node means, so we have to mention with the wait, and then we can go with the recursive method. Okay, so this is one of the sample structure for the ordering level. Okay, so first one, so what are all the possible, and then until the fourth node we have to visit, again we have to come for the nearest node of the backtracking process, and then it will be going into that. Okay, and this is one of the adjacency list for the thing. So where what are all the nodes it will be just connected, where we have visited, everything we have to do. So A, B, C in the order. A, it will be connected to the B and D, and then C and F, and then Cth column E, G, H, and then E, H, and then B, F as the nearest node, and then again A, B, like that. Okay, so this is one of the adjacency list for maintaining the graph model. And this is one of the DFS method for time taking the thing. So here the completeness, so we are having the complete and find the state space of the process in the final level. And then the next one is as the time complexity. So we have to maintain the time complexity as the very pakka manner, because it will be just to take over like the backtracking method also. So we can represent like the T of n, it will be taking like the n of m. Okay, so this is the thing, and here we can just m as the maximum depth of the limit over here, n as the node over here. So here we can just find the solution of the final path. Okay, with the help of the thing. So time complexity, whenever we can go with the level based information, we have to maintain the time complexity for this process. The next one, the space complexity. So we have to just maintaining the space complexity for storing the data and storing the value because of the traversal statement. So and then finally find the optimal path also. So we have to just find the thing, so not in the optimal path, so we can just find out the, we have to reach out the final goal. That is very important. Okay, so DFS method, it will be just connected into the branches of like the m. Okay, so the m as the maximum depth. Okay, and then optimal value, so always we have to find the optimal value. This is non-optimal value, but the whatever the node of value we have to reach out, so that the node we have to just reach out as a proper manner. That is very important thing. So these are all the information for the time and the complexity. So today's this presentation, and it will be just to overcome with the searching process. So searching, what is meant by the searching, and then what are all the searching components are there in the first level as a starting position to the goal state level, and followed by the state space method. It having the four kind of the important parameters for it will be take over. So that is important parameter. Whenever we can go with the problem, we have to just to do with these four component, that is a completeness, and then time complexity, space complexity, and then optimality. Also the four important thing we have to just analyze with the each and every method of information. That is very important. And follow by that we have just mentioning the some of the real world problem also. So what are the thing, it will be linked into that. And follow by the, we are having the search algorithm as a two type of the algorithm. So one for the uninformed and then informed. So uninformed, we are discussing what is meant by the uninformed as a blind search method. So as a informed means, it should be like a takeover like the heuristic search method also. In follow by the uninformed, we are having the types of the uninformed search. In the particular uninformed, we have just discussed the three important thing. Okay, so like the breadth first search, and then uniform cost search, and then DFS. So these among three topics, so we have discussed the properly as the parameter of state space also. So these are also the important thing for we have discussed for today session, and then in this PPT. So this is the important thing for the state space search until the DFS method. Thank you.